Hey everybody, welcome back. We are doing a unit on linear graphs and equations, and this is part 2. Our discussion today is reviewing slope and introducing the slope formula. Let's review a line with positive slope. If we put our thoughts and imagination on the far left portion of the line and moved across the line, we would be going in an upward direction. I think everybody associates up with positive. Similarly, in a negative sloping line, if we imagined ourselves to be on the far left portion and moved across the line, we would go down. Down is negative. As a line with zero slope moves left to right, it does not go up or down. A line with undefined slope does not go left or right. It's a vertical line. It only goes up and down. Hey, this is math class and we do problems. If you are answering these questions at Socrative or Google Forms, and I refer to a number from the video, I mean the number in the upper left-hand corner, which best describes the slope of line L. Let's use our imagination. Start on the left side, go across the line. We went down, so the answer is B, negative. Number 2 is a vertical line. Remember what we said about its slope? Since the line does not go left or right, it only goes up and down. We say the slope is undefined. Remember, the slope is a ratio of a line's vertical change in direction to its horizontal change in direction. We can use that definition to help us interpret the slope of line L in number 3. Remember, the word per means to divide, so the slope can be the vertical change in direction per the horizontal change in direction. Vertical changes in direction occur along the y-axis, and horizontal changes in direction occur along the x-axis. Therefore, number 3 is B, acres per goat. Also, let us recall lattice points. So in a problem like number 4, we need to identify lattice. And it is just where the grid lines cross. It is very easy to understand that B is not lattice, D is not lattice, and E is not lattice. But A, C, and F are, because these points exist on the grid lines. So the answer to number 4 is D. Lattice points can help us to find the slope of line L. We should be able to see that this has 1, 2, 3, 4 lattice points. If you are answering this at Socrative or Google Forms, just put the number 4, do not write a sentence. Number 6, what is the slope of line L? We can use any 2 of these lattice points to find the slope. The vertical change in direction is 2. The horizontal change in direction is 6. 2, 6 reduces to 1/3, and that is the answer to number 6. It is worth noting that if we started at this point and got our vertical change going this way, it would be -2, and our horizontal change going this way, it would be -6. Either way, we get an answer of positive 1/3. Let's do what we came here to do today. Let's develop a formula for finding slope given the coordinates of 2 points. Let's start by picking a letter to represent slope. We might want to pick the letter S. No, that's no good. We might want to pick the letter P. Well, that's no good either. We want to use the letter that, regardless of where we live, whether that be Georgia, Louisiana, Nebraska, or Maine, we all use the same letter, and that letter is M. You might be thinking, M, what? That's crazy. So let's ask Google, why M for slope? You may want to read this whole explanation, but let's just read the first part. It is not known why the letter M was chosen for slope. For simplicity of developing this formula, we are only going to use quadrant 1. But keep in mind, it does not matter whether you use quadrant 1, 2, 3, or 4. The slope formula is going to work. Let's start by graphing 2 points. Let's graph the point 10, 9. You know how to do that. We'd go right 10, up 9. Now let's graph the point 2, 3. That is very easy. Right 2, up 3. Let's draw the line between the 2 points and talk about the vertical change in direction between these points. We can start at this point and go up a total of 6 spaces to get a vertical change in direction of 6. Or we could start at the other point and go down to get a vertical change in direction of -6. Let's translate both of these segments over to the y-axis like that. Let's look at the endpoints of the segments. They are a 9 and a 3. Well, I will be doggone. We could obtain the vertical changes in direction by subtracting 9 and 3. One way to get positive 6 and the other way to get negative 6. Don't you just love mathematics? In fact, these coordinates are over here. There was the 9 and there is the 3. We don't even need a graph to obtain these 6's. I mean, come on now, that's deserving of one big wow. Now let's talk about the horizontal changes in direction. When we used this point as our starting point, we went up 6. Now we would have to go to the right 8 spaces to get to the other point. When we started here, we went down 6, and we would have to go left 8 spaces to get where we're trying to go. Let's get rid of these 8's and translate the segments to the x-axis. Like that, we can see that the endpoints of these segments are a 2 and a 10. Well, guess what? 2 minus 10 is negative 8, and 10 minus 2 is positive 8. And wouldn't you know it, once again, the 10 and the 2 occur in the original points. I continue to be amazed that we do not need a graph to get this 8 or negative 8. I think we are now ready to talk about the slope formula. Remember, we designate slope by the letter M. And if the vertical change in direction can be obtained by subtracting the y-coordinates, then by all means, let's subtract the y-coordinates. Likewise, if the horizontal change in direction can be obtained by subtracting the x-coordinates, then let's do that. But we have to be careful. There are 2 vertical changes in direction, a 6 and negative 6 for this problem. There are also 2 horizontal changes in direction. We have to make sure that we start at one point and continue to the other point. And there are 2 paths for that. We cannot get the vertical change in direction from one path and make a ratio with the wrong horizontal change in direction. That would give us a slope of negative 3/4, and that's not right. So we must pick a beginning and an end. We could begin and end this way, or begin and end that way. But since we are doing this without a graph and using a formula, let's just look at the coordinates. We could begin and end this way, or begin and end that way. So we might want to think of our formula as the end y minus the beginning y on top, and the end x minus the beginning x on bottom. But in mathematics, we do not call something the end y, we call it y sub 2. Likewise, the end x is called x sub 2. And the beginning y's and x values are called y sub 1 and x sub 1. Number 7, what is the slope of the line that passes through the points 10, 9, and 2, 3? Let's identify 10, 9 as the beginning point and 2, 3 as the end point. Let's substitute. Let's kick out y2, and in its place we put 3. Let's kick out x2 and replace it with 2. Now let's do the beginning point. Let's kick out y1 and put in 9. Finally, let's kick out x1 and put in its place 10. 3 minus 9 is negative 6. 2 minus 10 is negative 8. This fraction reduces to positive 3/4. And we see the values that we already obtained in the graphs. Since this is the first time we have used this formula, let's switch the beginning and end points to make sure that it does not matter which one we pick as the beginning or as the end. Remember, y2 and x2 represent the end point. So let's kick out y2 and x2. 9 is a y-coordinate and 10 is an x-coordinate. That was a lot of fun. Let's put in the beginning point. Let's kick out y1 and x1, and in their places we will put the 3 for y and the 2 for x. 9 minus 3 is 6, 10 minus 2 is 8, and once again we get the slope of this line to be positive 3/4. I think everybody is real happy about that. In our graph, that would have been this path that produced positive 6 and positive 8. You know what I think we need? We need a new problem with some new coordinates. Keep in mind, we could draw a graph of this situation. The point -1, -4 is right here, and the point 8, -7 is over here. Then we could graph the line and get a vertical and horizontal change in direction between the 2 points to calculate the slope. But we are having so much fun with the formula, let's use it. Let's establish a beginning point and an end point. Remember, y2 and x2 represent the end, So let's substitute -7 for y2 and 8 for x2. Y1 and x1 represent the beginning point. Let's put in -4 for y1 and -1 for x1. -7 minus -4 is -3. 8 minus -1 is 9. This fraction reduces to -1/3. So the answer to number 8 is -1/3. Keep in mind that this -1 and this +8 are the endpoints of this line segment right here. Similarly, this -7 and this -4 are the endpoints of this line segment right here. It is really easy to forget that, especially when we're doing a problem like number 9. Number 9 has a coordinate of 18 and another one of -12. These values do not fit on a standard 10 by 10 grid, so a graph is not always the best thing. We could draw a quick sketch of 18, 4, which would give us a point here, and 0, -12, which would give us a point here, so we should be able to visualize that the slope of our line is positive. Let's establish a beginning point and an end point. Let's kick out the end coordinates of the formula and put in the end coordinates of the specific point. Let's do the same thing for the beginning point. -12 goes for y1, 0 for x1. 4 minus -12 is 16. 18 minus 0 is 18. And 16/18 reduces to +8/9. When we compare that to our quick sketch, we get a really nice feeling that what we have done is correct. Number 10 and last problem of the day, which always makes me really sad because I'm going to miss every one. We should know that the coordinates 199 and 212 are not going to fit on a standard grid. So let's draw a quick sketch. Let's say 212 is there and -18 is here. That gives us this point, and 199 is here, 8 is here. That gives us this point. We know that the slope is negative, but that's all this quick sketch gives us because of the scale of the x-axis versus the y-axis. Let's establish a beginning and an end point. Let's kick out the end point in the formula. Let's put in 8 for y2 and 199 for x2. y1 and x1 represent the beginning point. Let's substitute -18 for y1 and 212 for x1. 8 minus -18 is 26. 199 minus 212 is -13. 26 divided by -13 is -2. And that's a pretty good match to our quick sketch. Everybody, I had a whole lot of fun today talking about the slope formula with you, and I can't wait to see you next time.